Oh, what? Oh, okay, it works. I thought it wasn't working. Anyway, hi. Is it Saturday? Yes, it is. Happy Saturday. Good morning or any other time of day that is possible. Yeah, I made it back. Oh, hi. Hello. What's up? Hi, Coffee. Um, I am back, and yes, let's live for today for now. What's on the agenda for today? Let's see. So, I literally I was preparing to start the stream and I was like, uh-oh, I didn't let this finish. Like it didn't run all the way. It ran like halfway. I just forgot that it existed. So I will continue with the different style of fine-tuning training. But we don't really have a result on our different epochs. Maybe I could run them both later. Oh, hello. Nishu. I'm new to Python. I wanna learn data science. Cool. That's cool. Where are you starting? I suggest you go to Free Code Camp. If you're like super new to Python. It's like, oh, sorry, I scratched the mic. It's like I'd say the best place for a really beginner person. Sure. Free Code Camp. Free Code Camp. Free Code Camp. I will put it in the chat for you. You will have to just, you know what? There we go. Oh God, no. That's a blog. That's not what we want. We want their courses. Wow, they have changed their style. Wait, let's go through it together. You know what? I don't want to leave you in the dark. You're welcome. I guess they changed their style. So when you say get started, you ask me to log in. You have to log in, which is fine. It's normal. But there we go. I suggest you go through as much as you can, like just start. Even though, since you're like, you know what, I just want Python, then that would be, I'm guessing, somewhere around here. This up here is web development and it's Java. Sorry, JavaScript. Anyway, yeah. Is there like anything that says Python? Okay, that's, okay, yeah. You can start from 8 and go all the way down as far as you feel like it. And here is the link in the chat. Yeah, I think back in my day, Free Code Camp didn't exist. I mean, it did start existing pretty early on, but what is the other website that helps you learn coding? Code Academy? Yeah, I think. They are so much. How much math do you need to know for data science? You are doing so. You are digital marketing. Okay. I'd say don't be like threatened or afraid by however much math is needed. Like, for example, the math you use, just knowing how to use it is enough. Hello, hi Oliver, what's up? Roll. Okay, I got it as in like you're down that road. Like, anyway. So don't be afraid of the math. My math is very bad. Like I failed math in three times? Was it 3 times or twice? I think it was 3 times. During like my bachelor's. So yeah, just if you know what is available, like when you learn, and Free Code Camp has a lot of projects, so don't be afraid, because starting with projects is better. As far as I know, I have not done the Python side. I've done the web development side. So yeah, just like, for example, a silly example would be like, what is square root? If you know how to use it, that's a silly example, but like, just knowing how to use it is enough. You don't need to know the details. You don't need to prove anything. You know, I hope that made sense. Knowing how to use it is enough. That's what I mean to say. Okay, got it. And I hope that courses teach you that side. And also don't pause there, because like even Free Code Camp has a YouTube channel with tons of tutorials, like people explaining things. So yeah, they're a really good resource for beginners. That's for sure. I think I said that yesterday, and I've been thinking about it. Like, I want to try. I do give a lot of advice, even though I don't feel confident, but I do want to try to answer people's questions more on social media. If like people want, for example, like your question, like I've been thinking about like making reels based on frequently asked questions that I get. Like one of the most frequent ones is about choosing a master's degree, which like I'm stumped, but I know how to get there in a way, like how I got there. Yeah, that's anyway. It's mostly like, this is what I did. If you feel like it, do it. If not, choose another path, basically. Yeah, many resources. Can't go beyond if else. That's all right. Yeah, it's pretty tough, especially if the concepts are new. But I think sometimes choice overload is a problem. Like, pick something, go as far as you can with it. But also, like, for example, if you find something interesting, try to go there instead of like doing something you don't find interesting. Like, if in a course you are stumped with one concept, but you like what's coming next, jump. Who cares? You can always go back. And also, like, start using ChatGPT or other things to answer like simple questions, because they know a lot. Like Claude Sonnet is really good with programming, and it's free enough. Like, you have some limited chat. It's not as free as ChatGPT, but it's free enough. Good luck. Okay, so we fine-tuned just using trainer and hyperparameters, but now we're fine-tuning with accelerate, which I'm guessing, based on what I saw, like when you scroll down, it's a lot more hands-on. Like, you know what's happening inside the loop. So sure. You're welcome. Yeah, let me know if you have more questions, or if there's anything else you can contact us wherever. Socials are in the description. As we saw, and by us I do mean the community, the little corner of the internet that we have. As we saw with the trainer, fine-tuning a masked language model is very similar to the text classification example. I swear I remember nothing from chapter 3. Anyway, in fact, the only subtlety is the use of not spatial, right? Data collator. And we've already covered that. Yes, we did. However, we saw that our special Data collator for language modeling also applies random masking with each evaluation, which is not what we wanted. Yeah. So we'll see some fluctuations in our perplexity score with each training run. One way to eliminate this source of randomness is to apply the masking once on the whole test set and then use the default one. To collect. What the hell? That makes no sense. For some reason. Why? Why did my character just run away? I'll try to fix it. Give me a sec. Okay. Oh, right. Hi. I'm back. Don't know why that happened, but it did. Okay. Yeah. So we applied on the whole test set and then we use the normal one to collect batches during evaluation. See how this works? Let's implement a simple function that applies the masking on a batch, similar to our first encounter. I think. Do I think? Can I think? No, I can't. Okay. I mean, I think I'll need to. Is that it? No, insert random mask. Yes. Dude, at least put a thing here that says this is the accelerate thing. There we go. Title. Okay. If I run this, we will get errors because none of the above code has been run. Whoops. What I could do is, tell you not to run. And then what else took a lot of time? I think that was about it. And just ask for, I think even perplexity took like 5 minutes. So I'm gonna, stop you. And then stop you and ask everybody else to run. So basically save and run above, run before. There we go. Okay. Yeah. So now I can't run anything because it's still running. But let's look at the code. Insert random mask. In our dictionary, we have index and value, right? And that's, we zip it, we collect it, so the batches, and then we just create a new mask column for each. Oh, sure. The masked data should be in a new column. We don't want to mess up our data. Like, don't edit directly. You need your raw data so that if you make any mistakes, you can just go back to it. Okay, next we'll apply this function to our test set and drop the unmasked columns. Oh, we drop it. Do we drop it like completely, or do we just like make a new data set? Because if it was me, I'd just make a new data set. So we can replace them with the masked ones. You can use the whole word masking by replacing the data collator above with the appropriate one, in which case you should remove the first line here. Moragul? What did it say? You, we, huh? We can, whole word masking. That did not work out for me well last time. I think I'm not gonna do that. Okay. I don't think, no, you can't. You can't see the tabs. But, Google Colab, can I hover? Yeah, okay, I can. Google Colab, the icon turns gray when it's running, and when it's finished running, it turns back to the orange color. So, like, you don't have to check it like I'm checking it. You can tell when it's finished, but, yes, sometimes. You know what? I'm a really patient person. Okay. I'm not gonna say I'm not patient. I am very, very patient. Okay. So for our eval, we are mapping him. Okay. Downsampled, removing the test. Okay. Batch true, insert random mask. So we're just putting this function on our whole data. Rename columns. Okay. Oh. Input ID becomes masked. We just put the word masked in front of everything. All right. We can then set up the data loaders as usual. All right. We'll use the default one. Yeah. Okay. So, you know what? Can we watch a linguistics video while waiting? Because I'd rather run the code than just going through the code. So let's watch, because I think it just takes a few more minutes. Yeah. Oh, wow. You know what? Actually, it's fine. We can do that. Should it be linguistics or should it be RAG? Because that was actually really interesting from yesterday. Is it already done? No. Let's continue from yesterday.
Even with intelligent training of dense embeddings, however, there still are problems. And the biggest problem that you face when you're looking at something like crossing coders, when you're looking at dense embeddings, is that in order to form a good dense embedding, you need to kind of know in advance what you're looking for, right? Because you're taking a long document, you're condensing it down into a single embedding. And
by the way, yesterday I YouTube the cool, the amazing, the lovely YouTube algorithm recommended a computer file video that is
in a previous
about rags. So that, like, the way they explain it is way simpler. Sorry. Volume is down. I think I turned the volume down yesterday, or did I not? Hold up. Actually, my volume is all the way up. I'm sorry. Our professor is being not loud. Oh, shoot. Does that make a difference? Hold up. Let's see if it makes a difference for you.
Taking a long document, you're condensing it down into a single embedding, or a long passage, and you're condensing it down to a single embedding. And so if during that condensation process, actually there's other information that is relevant to a query, but you have to throw out because of the limited embedding capacity.
Is it any better? I think it is. Oh, okay. Was that like this like the whole time? I don't know. Anyway, that one, like yesterday we had a lot of questions about rags. So I think this video answers maybe I didn't watch it the whole way, by the way. I think I was like, I'm gonna save it for the stream. Has anyone watched it? Because it came out yesterday, no? Oh wow, came out 5 days ago. I'm jumping from topic to topic, but I want to watch this. Okay. Class. Yeah. Like too much detail where you don't get the overall idea sometimes. Not always, sometimes. So when someone explains to you like you're 5, you're like, oh wow, that's simpler.
In this video, we looked at LLMs and whether or not they are going to continue to get way better or they're going to sort of plateau out. We're not going to keep talking about that today, as you're pleased to know. But I was interested in, some of the things that LLMs we were talking about that they don't do well. So, maybe they aren't good at talking about very niche subjects that haven't been well represented in the training set. How could you improve their performance on those areas? So maybe what we want to do is use the ability of a large language model to move text around and convert text and summarize text, but in a way that's perhaps a little bit more specific to some text we're interested in, so that the accuracy is better. That's the idea. So what we're going to look at today is something called Retrieval Augmented Generation, or RAG. And very simply, we're just going to take our query, we're going to combine it with some actual data and look at them at the same time. You can actually see this already happening. So if you go to Google and you search for something, or you go to Bing and you search for something, often an AI, in some sense, will pop up and try and tell you about that thing. In my experience, that's somewhat helpful, but actually I just wanted the link that was the first link down. What this is doing is something called RAG, or Retrieval Augmented Generation. So the idea is we know what we've asked about. We might not have all the information we need in the weights of the network.
So our actual query, the run is finished. The whole query document thing, he explains that like way better.
Already, it might not know about these things, but what it can do is summarize text. So maybe we should load in a website to do with that subject and have a look at that at the same time. So when Bing or some other search engine does this, what they're doing is they're bringing in sources of information, that retrieval, and then they're adding that into that process, answering hopefully better text output. Right? And you can see also it has the advantage that it also allows it to cite its sources. So instead of just saying, yeah, this is the truth about this thing, you can be like, well, where's the website you actually read that so I can verify this for myself? Right? That's something that's quite useful to do. Well, normally we would have something like an LLM and something like this. So this might be ChatGPT, GPT-4, it might be Llama 2 or some other model. There's lots of them now. And we're going to put in our query. That's a G. So I'm going to put in my query. Now, the query will be a question about something. So, what is the capacity of some football stadium? Right? There's been the Euros on, so we can talk about that. Although I don't have very many opinions. England not doing well enough as always. So we're going to put in our query, what is the capacity of this stadium? Now, the LLM...
There was a game yesterday. Wait, no, it was the day before yesterday. Anyway, there was a football game. Football meaning soccer, Anyway. Yes. It was Korea versus Palestine. And I was like, who do I cheer for? Thank God it ended in a draw.
Might get that right. It might know because it's read the Wikipedia articles as part of the training process. But a better way of getting accuracy for this would be to bring in some sort of data, right? So bring in data which we're going to get from the internet live, and then we can combine that with our query with a big plus symbol, and that's going to go into our LLM, and then it's going to be our answer. Now,
really? Do they tell when they recorded it? I guess not. Yeah, Llama 3's been out for a while.
The reason that that's effective is because an LLM is quite good at paraphrasing text. If you say, here's a paragraph that I wrote that's not very good, please rewrite it for me, that's one of the things they can do quite well. Or at least better than something where you're...
I'll try not to interrupt them as much, but like number file and computer file videos like inspire me to want to be a professor or a lecturer, at the very least. Because like they're so good at explaining things, and I bet they do that all the time.
You're just asking them to come up with data out of nowhere. And this doesn't have to be a Wikipedia page. This could be your stock prices. It could be information on ticket sales. It could be some information on your company. So maybe you're trying to run a tech support for your internal staff, and you can draw in information with frequently asked questions in it, and then it can answer those questions in a sort of more natural way. And
aren't RAGs used to update models without having to just do the whole thing from zero? Like updated information that gets updated way too much, you just give it in an easier way than retraining and fine-tuning and all of that.
Benefit, I suppose, would be that they can ask it questions directly as if it was a person, when obviously it's not. But maybe slightly more pleasant experience than just trying to scroll down a website to find the exact thing you need, or searching on an internal website and getting just lost in a bunch of pages that don't have the information in you want. This is actually very, very straightforward.
Oh my God, searching websites, like that's a whole thing. Like just right now, I was trying to search for the course. There should be like a website guide that tells you where something is. I mean, I know most websites have the bot that you can ask, but better. Oh yeah, I know he has a oh, okay. I know even Tom, the guy who quit YouTube and does Lateral podcast, the red t-shirt guy, also has videos on Numberphile or Computerphile, I don't know. So yeah, you're right. They don't have to be professors or lecturers. They're just people who are good at explaining stuff.
Process. There are lots of libraries that can help you do this, but the idea is that you're actually going to create a bigger query or a bigger prompt for your LLM based on your query and any data sources.
Does this stop or combat the hallucination thing? Because obviously there's a big problem with large language models where they kind of just guess what you want to hear.
Yeah, they're trained to produce next words, and sometimes those next words are meant just to look nice and not be factually accurate. So I guess having tried this out a little bit, my feeling is that it does help a bit. It won't, of course, completely stop an LLM from saying what it wants, right? And it might, for example, misread, in inverted commas, the information, right? So maybe you query some data from Wikipedia, but the information isn't in the Wikipedia article that you need. Or maybe it is, but it's buried among a bunch of tables. And
nuanced or whatever.
Yeah, and there are some models that have very, very large inputs. So Gemini, for example, the Llama model has an input of 8,000 tokens. So if you imagine you give it a 5,000 word document and say, what's that specific bit of information I need, it may find it, it may not find it, right? I would say the chances of it completely making something up are at least reduced, but that's just my personal feeling on the matter. I would
personal feeling. I also have like the same question of like, how do I know what I'm giving it is the right thing for the query? Like, for example, the example that's on my mind is like going to a university website, asking questions about admission, about just, like courses, and it should be updated based on like the most recent update. And I guess there is like document that tells that is updated based on this year's information. But yeah, it should be a long document. Anyway, I'm gonna hide my face for a second, okay?
Say, as always in these situations, maybe we can have some scientific data on this. Let me show you a little bit about, in a very simple level, how it works. Bearing in mind there are lots of libraries for doing this and lots of different ways to do it. So we might use a library like LangChain to do this. LangChain is a library that allows you to do things like RAG and other ways of interfacing with LLMs beyond simply giving them a string and reading different tokens back. So the idea is we have a query from the user, and then that query is going to be augmented by some other data. So let's say the user wants you to summarize a paper that they've read. So what you would do is you would take the PDF of that paper and you need to put it into the large language model. Now, that's going to need some kind of retrieval process that allows you to scrape the text.
You can't be serious. Like when I give Plot Sonnet a document, that's not RAG. That's just input.
From that PDF, right? So maybe we've got some data source.
Right? Is it?
And the problem with that data source is maybe it's not in the correct format. Actually, getting information out of Wikipedia is not too difficult because they make that nice and easy. But maybe your data is a PDF or it's an image or something more complicated than this. So you need some kind of conversion or some kind of data processing. So I'm just going to write, I don't know, processing. And this is going to be our sort of processed data or our final data. So this is our data that we want to put into our model. Now we have something called a prompt template. Now a prompt template is going to include all of the information that the LLM is going to have directly into its context. So this could include system information like you are a chatbot trained by OpenAI, right? Or it could be...
I think we saw, was it Whisper? No, was it? No, it was ChatGPT. Why did I think of Whisper? Template in the CMU course. Assistant something. Like, it has a template that it expects.
More specific instructions like, I'm going to give you some data, I'm going to give you a query, please answer that based on that, right? And don't go off piece and write poems about pirates. It will still do this, by the way, if you ask. So this prompt template has in it instructions, but it also has a place where this data will go and a place where the query will go. So maybe it has instructions, and the instructions might be really straightforward, like you're going to receive some context, you're going to receive a query, off you go, right? Then it has a place for the data or the context or the information or whatever. It might have more than one place, so maybe there's sort of numerical results, so maybe numbers in here in some way. And then you have your query, which is the actual prompt that the users put in, and then maybe you have final instructions or some other information, right? And then this is going to be converted into a giant prompt of tokens, which goes into the large language model, and then it makes its next word prediction and it spits out an answer, right? So I've actually implemented one of these. I say implemented, I joined together a couple of libraries and took the lazy way out, and we can see this working. Right, so it's football time, so we're going to...
I'm glad that he thinks he takes lazy ways out as well. Ooh, I like his markers.
Load up a stadium from Berlin where part of the Euros is being held, and we're going to grab that information from Wikipedia and we're going to stick it into here and hope that we can answer questions about it.
Wait, is that really RAG? Like just giving a document to a language model?
That's the idea. And this might be slightly more accurate, for example, than if we just ask questions without any kind of context being added at all. So Ollama is the library I'm using to actually run the large language model. So Ollama is a nice open source library where you can run locally hosted versions of large language models. I'm running the Llama models here, which is where the name comes from. Those are released by Meta and they're open source. So they...
Focus on Neubig lecture has been finding which document to give. The focus has been on how to retrieve the correct document. Yeah, you're right. Like finding the most relevant document, right?
This particular model, for example, is 70 billion parameters, which is pretty vast. Not as big as ChatGPT-4, but big enough to get pretty good text-to-text translation. I'm also using a library called LangChain, which allows me to do the prompt templates and things like this. LangChain does a lot of other stuff that I'm not using. So, for example, there's a thing called LangGraph, which allows you to have LLMs communicating with other LLMs, for example. And you can do all kinds of other stuff, like have them call functions and...
Yeah? Okay. A system that finds a document gives it... Okay. Yeah, that makes sense. Because user gives input, whatever it is. Like, even though you can give... the input can be like a 10-page document, it's still input. Like, it's just terminology, I think.
Run maps and generate images and so on and so forth. So this is a very, very simple piece of code. All I'm doing is I've got a couple of functions which allow us to grab content off Wikipedia, and I found one of the divs or the main parts of the website in HTML is called MW body content, and that thing is essentially where the main text of the article is held. So I'm literally just grabbing the Olympiastadion Berlin Wikipedia page, I'm passing it through a couple of very, very simple filters to get the right bit of the web page and to strip out all of the HTML so it's just text. Now you could do this in a much better way than I'm doing, because you imagine you're going to get bits of image, links, and there's no heading information, so there's no kind of structure to the document anymore, but it will be good enough. I'm going to grab that and then I'm going to stick it in when I make my query. So then I have something called a prompt template. I have a really simple one. You could be much more complex with your prompt templates. So mine just says you're an AI assistant who answers questions with the provided context, and then it has this is the context, this is the question, and this is where you're going to put your answer, right? And I have these placeholders of context and question where that's where LangChain will insert the content that I've given it and the query that I've given it. And then that's pretty much it. So I'm going to create a new alarm.
I'm really distracted by the whiteboard behind him because it needs cleaning. Like, I know it's removed, but it needs further cleaning.
New Llama model, and I'm going to point it at the Llama 3 70 billion model, which is running on our servers. I'm going to create a chain where we get the Wikipedia web data, and then we pass it through our prompt. We pass it through a llama, and then we convert it to a string. And I'm going to ask, could you tell me a bit about this stadium in a really enthusiastic way aimed at kids? Right, something like that.
That's
Try
cute.
and make this a bit more exciting. I'm someone who has a passing interest only in football, so maybe this will be good for getting me more excited as well.
Okay.
And then we're just going to invoke that chain, and all of this will run behind the scenes for us. So you can see that actually bringing in extra data is really not very complicated, and I haven't done much in here in terms of code at all. So let's run this now. So I'm going to bring up my prompt, so python rag.py, and it's going to trot off and it's going to run our large language model. Now this might take a while because we haven't been asking anything of this large language model, and it has to spin it up, it has to get the GPU ready, it has to initialize all the memory, some 33 gigabytes of memory if I recall.
Wow.
That's in just on the graphics card, so it takes a little while. If you run it multiple times, it's a bit faster. You can imagine that if you were running this, let's say on Bing, you need to have a lot of servers primed and ready to serve people with queries. I think it takes about 30 seconds the first time, and then about 5 to 10 seconds for another one. I'm sure I could speed that up by being more competent with my coding. Here we go. All right. So, oh my gosh, kids, let me tell you about the amazing Olympia Stadion in Berlin, Germany. Right.
So, vocation though, you could be a kids' TV.
Yeah, I could. Right. I'll use it to script all my future content. So what it's done actually is quite good. So.
Oh, that's funny. You mentioned Llama 3. Ah, okay. All right, so it's pretty recent. Hi Noir, what's up? Let me know what is on the learning agenda today. What are you learning today? Because like each time I see him, like, get out of here, go study. Very hyped this morning. Oh, hi, alaikum assalam. Oh, يسعد صباحك. Each time I'm reading, like, صباحك, not صباحك. Got it. I am a woman. كيف حالك? Yeah. اليوم. الحمد لله. Trying to speak Arabic. Let's do this. كلش زين. Yeah. What is weekend in Arabic? Help me. I mean, Jum'ah is the only thing that comes to my mind. Continuous random variables and restarting supervised learning from a course I bought last night. Ooh, okay. When you buy a course, please make sure to finish it, because otherwise your money goes to waste. Good luck with that. Yeah. عطلة وخلاص. So just trying to hype myself up for the work week. There, that was half Arabic, half English. I did it. Good job. Okay. We're watching a video, by the way. So I am going to continue it.
Yeah, I could. I'll use it to script all my future content. So what it's done actually is quite good. So it's taken, yes, it's in the style that's suitable for kids. That's great. But it has got some interesting information. So 74,000 capacity. It's hosted concerts. It's got VIP areas and so on and so forth. So it has drawn information from the Wikipedia article and put it in here. The reason that search engines are doing this is because the content will, generally speaking, be better. Of course, there'll be counterexamples that are sometimes funny, sometimes a bit worrying about how this works. But the idea is that if you have the text...
Shukran, Ahmed, shukran. Thank you for cheering me on.
...text right there in the context, it's at least more likely than it is just hoping that the training process itself has memorized all these facts. It's perhaps worth remembering that these models are very, very big. So this is 70 billion parameters. That's a lot of different things you can learn. ChatGPT is over double this size, right? And so there's a good chance it'll learn a load about the Olympia Stadion Berlin already, right? And you'll be able to answer questions like, you know, ChatGPT will be able to tell you about these stadiums and things like that. I guess the thing is that when you have things that are less common, right, or more difficult, that's when this data retrieval might help, or things that are very specific to your use case. So maybe you have specific content from your company or something like this. That is not going to be in the training set, we hope. And so in that case, they won't be able to answer these questions. And so it's those kind of times where bringing in extra data might help.
Hey everyone, thanks for watching this video. It was brought to you by Jane Street. And Jane Street are looking for the next wave of curious and passionate people to...
Not gonna not watch that, but also I'm not gonna watch that. Like I'm gonna let it play. Okay. So that was useful. That was high level useful. Now if I go back to this video, I'd like to think that my brain will connect some dots. But before that, we really need to get going on this side. Oh yeah, I did not run the code for inserting random mask, and then the mapping. Oh, that should take time as well. No? Oh wow, okay. It's downsized, that's why. Downsampled. And then, what was this one? Put it all together, basically? Did I run something that I had not read about? No? Preparing it for evaluation. Jane Streetwear. Okay, I don't know. I think the video just ended. Yeah. I mean, I have watched videos about Sam Bankman, but is his actual name Bankman? No, right? You're kidding. Because it's Freed. Sam, is it? No, I've heard the full name multiple times. It has to be like self-written, you know, like Lord Voldemort. So from here on out, we are following the standard steps of accelerate. Does accelerate sound like a magic spell? The order of business, first order of business is to load a fresh version of the pre-trained model. Why? Because our last version is supposed to be fine-tuned. All right. Wait, where's our fresh faced model? We have Adam. Oh, there it is. All the way here. Okay. We have accelerator, which we prepare, model optimizer, train data loader, and eval data loader. And then we have scheduler. We're asking for 3 epochs. Is the code like too far? Bankman Freed, the parents share their last name. Wow. I'm just saying that like the name Bankman is very fitting. A person that has to do with money. Like having the name blacksmith and actually being a blacksmith, you know? Epoch of 3. Update per epoch, and then the steps, epoch times update. And that's our linear. I saw LR and I was like, learning rate? But no, it has to be linear. Scheduler. And then here's our fresh-faced model. Did I run to... Oh, 뭐야? No, that's the name that it will be. Still don't have our fresh-faced model. Anyway, I think I'm gonna just take the code because I don't trust my model to be clean. There you go. So optimizer and then prepare, we did that. And then configure, we have the model, the optimizer and data loaders are configured. Learning rate, oh, it is learning rate scheduler. Okay. Oh, yeah. Yep. It is learning rate. I saw linear and I was like, okay, maybe the L and R is from here, but no, it is learning rate. Got it. Oh no. Frame drop is 3%, which is nothing compared to what it used to be, but I'm still surprised that, okay, now it's getting better. The internet is not as, shoot, hi, no, later, thanks. I've been telling it to update later for like maybe 2 weeks. I really should update it. But like last time I updated it and it messed everything up. So anyway, that last time was a year ago, by the way. Yes, this is our name. And create a clone. Then create and clone the repository. We made it here. Create the, okay. We can do that from here. That's cool. With that done, it's just a simple matter of doing the whole loop, which I'm gonna need to read about it. Wait, what? We're not gonna read about it? We're just gonna look at the code? Okay, let's do that. Here's a repo. Wow, beautiful. I need to log in. Deprecated. Could I? Where is it? I didn't write it. I didn't write it. Take me somewhere that can fix this. Repository not found. You're right, maybe? Let's see. I can just manually make it. Why wasn't it found? Why wasn't it made? Yeah, that's yesterday's. I'm guessing it told me to go make it. Let me see if it told me to go and make it. I thought you made it. Okay, we need to do it. No. I thought you made it. Here's the name. I go for MIT most of the time. And then there you go. Now it's made. Try again. Oh, thank God. We have the progress bar. We have training. For each batch in the data loader, give me the output. This is loss. Accelerator backwards. Everything take a step. Eval. Give me the outputs. Look at loss. I'm not sure what's happening here. Just appending something. And then, does that concatenate? Calculate perplexity. If it's infinite, tell me. And this is our epoch, this is our perplexity. And then save and update, which means push to hub. Cool. That's actually not that, I mean, it's not that difficult. There we go. That's going to take time, right? Cool. I need to drink some. Okay. We've been able to evaluate perplexity with each epoch and ensure that multiple training runs are reproducible. And then you can use it. You can load it and then give it a text, which I guess we had text upstairs. And then ask for the prediction. Our model has clearly adapted to predict words that are more strongly associated with movies. Got it. Domain adaptation. See, that's the word. Domain. This is the word that I was looking for yesterday, because I say context, but domain is also a good thing to say, right? All right. So I'm gonna lower the volume. Tell me if it's too low. I don't think it will be, because their volume is pretty high.
What is domain adaptation? When fine-tuning a pre-trained model on a new dataset, the fine-tuned model we obtain will make predictions that are attuned to this new dataset. When the two models are trained with the same task, we can then compare their predictions on the same input. The predictions of the two models will be different in a way that reflects the differences between the two datasets, a phenomenon we call domain adaptation. Let's look at an example with masked language modeling. By comparing the outputs of the pre-trained Distilbert model with the version fine-tuned in Chapter 7 of the course, linked below. The pre-trained model makes generic predictions, whereas the fine-tuned model has its first two predictions linked to cinema. Since it was fine-tuned on a movie reviews dataset, it's perfectly normal to see it adapted its suggestions like this.
Ah, yeah, great movie, great film. And then idea is still there, deal is lower, adventure is lower. Notice
how it keeps the same prediction as the pre-trained model afterward. Even if the fine-tuned model adapts to the new dataset, it's not forgetting what it was pre-trained on. This is another example on a
Anyway.
Translation task. On top, we use the pre-trained French-English model, and at the bottom, the version we fine-tuned in Chapter 7. The top model is pre-trained on lots of text, and leaves technical English terms like plug-in an email and changes the translation. Both are perfectly understood by French people. The dataset picked for the fine-tuning is a dataset of technical text, where special attention was picked on translating everything in French. As a result, the fine-tuned model picked that habit and translated both plug-in and email.
Yes, fine-tuning is a good thing. Got it. As if I needed convincing. I did. Okay. This wraps up. Oh my god. We did it. I mean, we did it. There's an error. What the hell? Oh no, it's the old error. You're going. 16. Is there an error? Hold up. What? Did it restart? Oh, crashed all the available RAM. Fun. Anyway, you get the idea. You get the idea. I can rerun everything again, and I think I will. Because like I will be here for the next half an hour, so why the hell not? This wraps up our first experiment with training a language model In section 6, you'll learn how to train an autoregressive model like GPT-2 from scratch. Woohoo! Head over there if you'd like to see how you can pre-train your very own transformer model. What is that? To quantify the benefits of domain adaptation. That's a very fancy word. Fine-tune a classifier. I watched a recent Vlog Brothers video about hyphens, M-hyphens, N-hyphens, or something else. And that is another. Did you know there are 3 types of hyphens? I thought there were 2. Anyway, and now I'm seeing this one. I'm like, what is that? Classifier on the IMDb labels for both the pre-trained and the fine-tuned Dilbert checkpoints. You need a refresher? No, I'm good. Translation. Whoa. Translation with transformer. What are we using? Who are we using? What are we using? Okay, that's the data set. What model are we fine-tuning on? Show me, show me, show me. French? Okay. Helsinki NLP. Cool. I don't want to translate French. Well, we're gonna choose something else. Yes, it's not like coding if something doesn't go wrong, obviously. We were watching a live program yesterday, and someone was like, is it live? Like, they're doing really well. Like, it was live music, live singing. I was like, they're really well. And then the audio crashed, and the people were just laughing. I was like, see, proof that it was live. So yes. I think it's failure that makes us human, isn't it? So that was that. We shall jump to CMU. We're gonna pause here. Obviously, I'm not gonna start another thing, but I am really proud of myself for coming this far. Tap tap on the shoulder. Let's go to CMU for a bit and see how far we can go. By the way, from since yesterday, I've seen this figure from Khattab. I was like, that's an Arabic name. That's it. Okay. Let's continue.
Condensation process.
Oh, sorry. Voice has been lowered. Let's go back up. And there.
Actually, there's other information that is relevant to a query, but you have to throw out because of the limited embedding capacity. This causes you to, essentially fail at doing retrieval appropriately. So there's a
because information gets thrown out. What's the word where there isn't enough space? Cut off in a way? Yeah, there's a better word for it. Anyway.
A couple methods.
Truncated. Yes.
That can be used to fix this. So the first method is, in contrast to the bi-encoder, which is what I've been talking about at this point, where you kind of do full encoding of queries, full encoding of documents, and then do inner product search for a score. You can use a cross-encoder. And the way the cross-encoder works is you append the query and document, and then you run them through a model like a transformer model, and you calculate the output score. So the problem with this, this is great because it gives you maximum flexibility. Transformer models are powerful. You can assess relevance very well. The problem with this is this precludes approximate nearest neighbor lookup, because now you're running through many nonlinearities here. So this really can only be used for re-ranking documents, or even if you're doing retrieval over a very small number of documents. But if you really want maximal accuracy, I definitely would recommend doing something like this, because it can allow you to do kind of a second pass filtering over the most relevant looking documents to identify the ones you really want to add to your context. So then there are also approaches that are kind of in the middle of these two. The most famous one is Colbert. And I called this
Wow. There's one called Colbert. That's cool.
token level dense retrieval. It's also called late interaction in the Colbert paper. But the way it works is you use contextualized representations of all query and document tokens to compute a retrieval score. And so you do offline indexing of every token in the document.
Hmm?
And then based on this offline indexing of every token in the document, you then have a query encoder and you do matching between each token in the query and the highest scoring tokens in each document. And
Max similarity? Is that what the sim stands for?
the reason why this is good is it still allows you to encode all of the tokens in the document, but each of these similarity searches is still just a kind of maximum inner product search. And because of this, this allows you to
Find relevant answers to questions. Now I'm thinking, how do I stump this? How do I... Because like, I want to have a question where the answer has nothing to do with the exact words in the question. You know? Because like, I know a query has to be well thought out so that the answer is also good, but yeah. Like a really simple question of like, what is rocket science? Rocket science is, you know, useful, but the answer should be far more than that, you know?
each of these.
Okay. I guess if the word rocket science in a 100-page document is in 2 pages, then that's where the answer should be. You're right. It does matter. I'm just trying to stump it, though.
Searches efficiently and doesn't preclude you from running it over an entire database. The downside to this method may already be obvious, but in the traditional bioencoder, we have a single vector for each document. But here we have one vector for each token in the document. So basically, your vector database gets n times larger, where n is the number of tokens in the document. And there are certain methods to make this better, like you can compress each document to a smaller number of n, but still, this is definitely going to be more costly than looking up each token. So this is definitely something to consider if you want to get, you know, very good scores, and Colbert is a good implementation of that to start with if you're interested in trying it out. So this is a final thing. This is something that is a little bit different than all the other things I talked about before, but I've used it myself, and it actually can be pretty effective. It was also made at CMU, so by Liu Yu Gao, so I would like to promote our CMU work, of course. But the idea behind a hypothetical document embedding is that it's actually somewhat difficult to match a query and a document, right? Because a query is a very short, possibly ungrammatical output that's asking.
Oh yeah, yesterday I checked something with Cloud Sonnet, and I think, was it? Anyway, I knew there was a spelling mistake. I didn't fix it because like it should know. So yes, queries sometimes are just, you know, like when you ask Google something, you're like, even the word order is not correct. You just like keyword, keyword, keyword.
A question, and then a document is a very long output that's written in a different prose style, and you know, it might have lots of irrelevant information or boilerplate or fluff or something like that. So the idea behind a hypothetical document embedding is that...
Thank you! That scared me. Thanks for the subscription, for the subscribing. Merci. Thanks. Okay. I'm going back to the video. Thank you, thank you, thank you. Like, again, I am pleasantly surprised by the number of subscribers this channel has been getting the past, like, 2-3 weeks. Like each day, the number changes. I'm like, whoa, why? So thank you.
It's easier to match a document in a document than it is to match a query in a document. But the input to our model is a query, right? So what do we do? And so essentially what we do is we then take
Easier to match what to what? Query to query, then query to document? So we need to have a question and answer document?
To match a document in a document, document embedding is that it's easier to match a document in a document than it is to match a query in a document.
Oh.
But the input to our model is a query, right? So what do we do? And so essentially what we do is we then take a large language model, we feed it in a query, in a prompt, and say, generate a document that looks like it should be the answer to this query. And so then the LLM goes in and it generates a document, and hopefully this document looks more similar to the documents you want to retrieve than the...
Oh, wow, that's a really interesting idea. So you ask it to generate something. So, it's not only retrieval, it's generate, retrieve, and then update. Wait, maybe. Like too many steps, but also makes sense. Because like sometimes, there's an example, like if you have worked with clients and like as a developer, you don't always interface directly with the client. Sometimes there's a person that gets requirements and that person needs to translate between you and the client because they know technical words and they know the words of the business, and that's what the generator becomes the middle person, you know.
Than the original query does. And I've actually found this to be relatively effective at improving accuracy on kind of difficult tasks, especially ones that are out of domain from the trained models that I'm using. So I've gone through a whole bunch of methods, and I would like to finish up this section by giving some insight about which one you should be using.
Okay.
So my impression right now is that a good baseline to start out with is something like BM25. It's very easy to start out, and compared to embedding-based models, it tends to be relatively robust to new domains. So if you have a new domain,
He also said domain. Okay. Got it.
More or less guaranteed that BM25 will give you some performance, whereas embeddings may be really good, but they may be really bad, depending on how out of domain that is compared to your underlying embedding model. So, however, if you want to get the highest accuracy, definitely tuned models are going to be better. And if you're not worried about computation efficiency, using something like FullBear with kind of the token level retrieval will definitely give you good accuracy here. However, there's better support for bioencoder style models in kind of standard vector databases like FICE and Chroma and other things like that. So if you want a kind of easier method to get started very quickly, then using a bioencoder is probably the best way to go.
Okay.
Okay.
Yay! Wow, look at us. Look at us. Who would have thought that we would get to multiple...
Okay, so now moving on to actual...
pausing sessions in multiple places. Another error, which is crash. Got it. Crashing. Thanks, Oliver, for being here. Have a lovely restful sleep. Wish you all the best. Good luck. See you next time, whenever that might be. We will go here now. Wow, today is a learning day, isn't it? Yes. That comment is funny. Let me refresh this for no reason, and let's start.
Hi, I'm Taylor. Taylor, and welcome to Crash Course Linguistics. According to the word count feature in a document, a word is a thing with spaces around it. That's a useful definition if we're just trying to figure out how long an essay should be, but it's not a very good guide to defining what counts as a word. For example, doghouse is generally written without a space, while rabbit hole is written with one, but they feel like they should both be words. After all, sometimes people write doghouse with the space, and we could totally start writing rabbit-hole or even rabbit hole completely smushed together. Also, just because a word like hangry isn't in your dictionary doesn't mean it's not a word or that I'm not feeling it right now. Man, I should.
Yes. Bye and thank you. She's talking about hyphens. There's a K-pop group called N-hyphen, by the way.
Should have eaten a snack before this shoot. Anyway, today we're going to talk about how a linguist would answer the question, what even is a word? To a linguist, the word word has a big meaning and a small meaning. The big meaning of word is what we expect when we're looking something up in a dictionary. We'd expect to find a dictionary entry for rabbit hole because this phrase has a meaning that we can't figure out from the definitions of its individual parts. After looking up rabbit and hole, we wouldn't guess that rabbit hole means a place where a rabbit lives or a complicated or absorbing situation, like finding your...
Oh yeah. I was about to say, no, rabbit plus hole is very, like, self-explanatory, saying a place for a rabbit. But going down the rabbit hole, now that's a different thing.
Yourself down a Wikipedia rabbit hole at 2 a.m. after Googling what languages are spoken on the International Space Station. Its meaning is relatively unpredictable.
What languages are spoken on the International Space Station? I mean, I know people have to be multilingual, Russian, English, and maybe something else. Because there are a lot of cosmonauts. And there are parts of the ISS that are built by Russia. Yes. We have NASA, we have ESA, other countries like India, and also Russia. Anyway.
Predictable from its parts. Dictionary makers define one entry or unit as the largest unpredictable combinations of form and meaning. They call each of these units lexemes or lexical items because they're parts of a lexicon, which is another word for dictionary. In contrast, we wouldn't expect to find a dictionary entry for deep hole because if we look up deep and hole, we can figure out the meaning of the two combined. It's predictable. So deep and hole are both lexemes, while deep hole is not. When we think about a phrase like falling down rabbit holes, this is where the small meaning of word comes in. Here we can break the sentence into parts. Fall-ing down, rabbit, hole, and z. Even though we don't say ing or z by themselves, they have distinct meanings. For example, z indicates that there's more than one rabbit hole, and we can predict this from the meaning of rabbit hole and z together. But we can't separate rabbit into rab and it, even though it is a word, because rab doesn't mean anything on its own. Rab and it don't each have their own meanings that they're contributing to rabbit. The meaning of rabbit is unpredictable. Rabbit and z are examples of the smallest unpredictable combinations of form and meaning. Linguists call these units morphemes, and the study of them is...
Examples of the smallest unpredictable combination of form and meaning.
Morphology. That's morph, as in metamorphosis or anamorph. It's from a Greek word meaning shape or form, because morphemes can stick to each other to change the shape of a word. One reason it's helpful to divide language into morphemes is because it helps us see patterns across languages. A separate word in one language might be a part of a word in another language. For example, the phrase, I washed my feet, is a sentence with several words in Mandarin. The same idea is a single word with many morphemes in Murrin Pata and a lot of other Australian languages. If we just think of words rather than the morphemes that build words, we miss this and a lot of other interesting potential patterns. If we look at morphemes instead, we can see differences and similarities between languages in the information they can...
No, does it feel like they dipped out over? Is there a delay between audio and not audio? Video. Where? Like just one section or the whole video? Because I don't feel like it feels dubbed over. You want to check the video on your side to see if it feels like it's dubbed over?
convey, not just the number of words they use. There are a couple of different kinds of relationships that morphemes can have with each other. When we have a morpheme that can stand by itself, that's a free morpheme, like rabbit.
Huh? Did she? No, her voice is the same. No. Maybe. Yeah, no. I guess no. Like, I know recording in studios and not studios makes your voice change like a lot, but it's the same environment from the past videos. I don't think I put this on Discord. I'm gonna put this playlist on Discord so that later, if you feel like it, you can check. This is Crash Course Linguistics. Did I put it there? I have no idea. Crash. Don't crash. Crash Course Linguistics. Don't expect me to know the spelling for the word linguistics. Okay.
Can have with each other. When we have a morpheme that can stand by itself, that's a free morpheme, like rabbit or hole. When we have two or more free morphemes combined together, that's a compound, whether it's written with a space, a hyphen, or all joined together, such as doghouse, rabbit hole, or even rabbit hole fence sign. In American Sign Language, there are signs like and that are compounds composed of teach and learn, plus a variant of the sign person. Recognizing compounds allows us to see similarities between languages that we might have missed. In other languages, nouns might be linked by other words, like the sign of the fence of the hole of the rabbit. But English and German just put them all together into long compound nouns. The only difference is that English keeps spaces when writing long strings of nouns, while German doesn't write the spaces. So while it looks like English and German have very different ways of creating words, they actually often use the same compound nouns. Perhaps we could
Yeah, I love German words. Anyway.
We could call this the Deutsche Wörterübersetzungsproblem, or word in German translation problem. Meanwhile, when we have a morpheme that can't stand by itself, like the s in rabbits, that's a bound morpheme. Let's head over to the thought bubble to see more about how morphemes fit together. We can visualize morphemes as fitting together like the parts of a plant. In this metaphor, the most central part of a word is the root, and the other—
Yeah, she even said part of word, because like post tagging is a thing, part of word tagging in NLP. So that's basically that.
Other morphemes that are stuck or fixed onto it are affixes. So rabbit is made from the root rabbit and the affix s. Since the s affix in rabbits comes after the root, we can call it a—
Hold up. Post tagging is part of sentence, not word, right? Oh, got it. That's a word. Okay. Right?
suffix. If the word has an affix stuck on before the root, it's called a prefix. To extend our plant metaphor, when we add a morpheme to the root, this new unit becomes the stem for the next morpheme. And here's where it gets interesting. We can also have a word with several affixes at once, like untwistable, which has the prefix un, the root twist, and the suffix able. It sounds simple enough, but this word's meaning depends on whether untwist is a stem for able or whether twistable is a stem for un. It could mean able to be untwisted. That's untwist plus able. Or it could mean not able to be twisted. That's un plus—
Isn't this messed up? Like, this is messed up. It literally like has two different meanings.
twistable. Not every word with multiple affixes has more than one meaning, though. It all depends on how the word builds. At each stage, the stem has to work as a word by itself. So untwistable is ambiguous because untwist is a word, but twistable is also a word. In contrast, with a word like unrabbity, rabbity is a word, but unrabbit, that's not a word. So unrabbity only has one meaning.
This gets more called like, yeah, stemming, you're right. Lemmatization, I've heard that. I think separating words into their roots and affixes. True.
Rabbit, rabbity, unrabbitiness. This can go all the way up to lots and lots of affixes. That was the most thought bubbly of thought bubbles. The root is often a free morpheme, like rabbit, but the root isn't always free. Think of words like receive, deceive, perceive, and conceive. You can receive, and you can deceive, but can you just sieve? It's the same part in all these words, but it doesn't have its own independent meaning. It's a bound morpheme, just like s, but it's also the root. It's one of a handful of examples of bound roots in English. And in addition to prefixes and suffixes, there are some other kinds of affixes that can be attached to a root. Affixes can sometimes go in.
Sorry, she's not focused. Like, camera is not focused on her, and it's messing with me. But anyway.
Inside a word. This is called an infix, and in English it primarily happens with swear words or pseudo-swears. Fan-hecking-tastic. And for the completionists out there, there's also circumfixes, which have information attached to both the beginning and end of a word. English doesn't really do circumfixes, but Malay has 8 different ones. The meaning of the word changes only with the addition of both parts of the circumfix. So far, morphology is looking very neat and defined. You can make words by stacking morphemes on roots to make longer stems. But morphology isn't always neat little packages of affixes. Sometimes one affix can hold more than one piece of information. This is known as fusional morphology because it's hard to tease out how each morpheme relates to a specific part of the meaning. It's all fused together. For example, as languages change over time, they often smush smaller words together, making free morphemes into bound morphemes. The English words not, none, never, and nothing all contained ne, the Old English word for not. And not itself gets smushed together in modern English words like didn't or dunno in French when a word ends in al.
I do wonder why we can't supplement subword tokenization with affix knowledge from a dictionary. We could, we should. Why we shouldn't? Yeah, linguists have done a lot of job, like they've done a lot of work. And we should work together. We should hold hands and do good work together. I guess it's not always clear cut, but if you make a model yourself, it should be how things go together. Like, I know there are models that expect sounds and not text, like normal text. So there are more linguistically focused stuff out there.
Like animal or journal, the suffix al indicates that it's masculine and that it's singular. You may not be familiar with the idea of words being masculine, but don't worry. For now,
I am. I've studied Arabic. I am.
Now let's just focus on how this suffix tells us 2 things about the word. To make it plural, you need to change the whole ending into aux, like animaux or journaux, to indicate both of these things. There were once 2 suffixes, one for masculine and one for plural, which we can still kind of see in the spelling. But aux is now simply pronounced o and indicates both. To further broaden our idea of morphology, we should mention there are ways of building meaning in words that go beyond adding affixes all in a single row. For example, some words in English can change their vowels instead of adding an affix, such as foot and feet, or sing, sang, and sung. In Arabic, Hebrew, and other Semitic languages, the root of the word is just the consonant, and then vowels are added in different...
I don't know why. Maybe I've forgotten, maybe I didn't know. I didn't realize that the word is the consonant part and vowels change. Wow, like maybe I just forgot. I don't know.
Configurations to create different related words. For example, this Arabic root means things having to do with books or writing, and from it we get kitab, meaning book, kutub, meaning books, katib, meaning writer, maktab, meaning office, and more. In American...
Right. Yeah. That's cool. That's really cool.
In sign language, nouns and their related verbs sometimes have the same hand shape and location, but different movement. For example, and occasionally, a language will change the word completely rather than adding a morpheme. Think about the English verb go, which is went in the past tense rather than goed, which would follow the regular patterns of English morphology. This process of completely replacing a word is called suppletion, and languages mostly use it with a handful of common words rather than as a systematic process. Thank goodness for that. If you thought conjugating verbs with different suffixes was hard, imagine having to learn a completely different word each time.
I don't have to imagine it. Like, I had to. We had like word lists that we memorized at school. And it was easier for me because my English was okay. But like people who were not used to it, like memorizing 50 words, that's not fun.
So let's get back to this tricky question of what a word is. Linguists don't really know, and that's actually fine. There are so many edge cases and exceptions about the word that when linguists need to be really precise, we use completely different terminology instead. We talk about morphemes, but when we're not zoomed in quite so closely, it's still totally okay to talk in terms of words, like when we're talking about combining words into longer phrases and sentences, like in our next video. See you next time. Thanks for watching this episode of Crash Course Linguistics, which is produced by Complexly and PBS. So, 2020 has been bad. PBS has a new show called Self-Evident that explores how we've been persevering.
Oh wow, September 2020. This is exactly 4 years ago. I wonder how much linguistics has changed since then. That was a joke. You know, because computer science versus linguistics. I hope they've found some words. What is a word? Starts sweating profusely. Okay. Come on, Haja. Should we stop here? I think I might stop here. Yes. And I'm gonna just let this go. Goodbye. Thank you for your service. There we go. Okay. I think hangry would be in the dictionary now. Oh, probably. Especially like, you know, Oxford Dictionary stuff. Like they say this word was added to the Oxford Dictionary. I remember when YOLO was like the word of the year or something. That was good times, good times. Yeah. I'm guessing a lot of slang goes into dictionary. I know that the word hangry is in a BTS song, so that's that. Yeah. Okay. Good. Very good. Nice. Wow. Exactly on the dot. Thank you. Good luck to everybody and all of us. 1 hour and a half. An hour and a half of streaming. Fun. I'm happy. Good luck. You know, because like I pray to have a good weekend and then I pray to have a good week. So right now I pray a good weekend to the people watching, and then inshallah a good work week for everybody. Yes. Yeah. My brain is like going around in circles because I have some things on my to-do list for today, but like, should I do it? I'm like, rest and also do whatever you feel like. Yeah. Yep. Okay. I guess that's it for today. Thank you for being here. I feel like today was like very, very clear, like, pause. That was nice. Tomorrow I'll see based on my energy level whether I have I can, because I should be able to oh hey, hello. Okay. But we'll see. I don't want my energy level to go like very down while I'm work, so we shall see about that. Yes, tomorrow, I mean next stream. There we go. That's what I want to say. We shall start with the translation. I'm guessing this has to do with fine-tuning as well. And then maybe the continuation of this. and the continuation of that. And if you find any cool resources, let me know, because like sometimes there are resources that help with our current learning, so that would be cool. Okay, thank you for joining us today. I should, yeah, I'll probably watch a Korean drama. There we go. That will make me happy. Yes. If you have any recommendations for K-drama, let me know. Otherwise, I'm gonna end the stream now, starting from a countdown of 5. Yes. See you next time, or not, depending on how life goes. Because, you know, you might be busy or I might be busy. So, until... Whoa. Sorry. My brain just went to a scene of Dracula that I was listening to yesterday. Because, you know, they say people are like ships passing, and there was a ship. See? My brain is not currently well. I'm kidding. It's just too many things inside. And when you verbalize, you're like, wait, this is happening in my brain. All right. See you next time. Ending the stream in 5, 4, 3, 2, and after 2, it's 1. So, yeah. Thank you.